My wife was telling me, you see, I don't know if we're actually live yet. So my wife was telling me that she read that people my age and her age pause for a recognizable amount of time before they start talking whenever they record something, and younger people don't pause like that. I'm not sure if this is a real thing or not, but apparently somebody wrote an article about it. So hopefully didn't stress anybody out with the pause there. And hey, this is Plutus PBL live coding, and we have an exciting one today. So Nelson graduated from the Plutus PBL course, took on a task with GPTE, and what we're playing with is approval processes. How do people how do we decide when work is done? So I'll give a quick opener for this. Here on the live version of GPTE on mainnet, we can see that there is a commitment to be distributed. The commitment was made by Nelson with the 222 prefix token. It was made to project number 3, which we can review up here. Here's project number 3. And so the task was to add some kind of project commitment status, right? So that every project card and project page, this is an example of a project page. These are examples of project cards right here. To add some logic so that we can see how many commitments there are, if there's open commitments, and even maybe some logic that allows people only to commit if multiple commitments is true. And so what we're playing with are approval processes. We're going to continue to talk about both the nature of these approval processes and the technical tooling that we'd like to build to formalize this on Thursdays at Live Coding. But the idea here is that somebody who completes something can give a quick presentation at Playground, or like we are here at Live Coding, get feedback, questions from the group, and then I'll just ask the question afterwards, does anybody object to this commitment being distributed to Nelson? Okay, and that's kind of what defines the consent process. Is we don't have to all be 100% over the moon thrilled about it, although we might find that we are, but just nobody has any serious objections to distributing that commitment. Any questions about the task or this early iteration of the process we're building here? Cool. I'm going to stop sharing. You should be able to screen share, Nelson, and take it away when you're ready. Hey, and welcome. Nelson, we can't hear you if you're talking yet.
You guys can hear me?
Yeah, gotcha.
So I was planning to put on a presentation, but this game, sorry about this. So I'm just gonna go ahead and talk about it and show you the code. So this project ID 0003 is the one I have chosen to work on, and the objective was, when we see these projects here, we don't know whether there is a commitment to that or not, and we want to highlight that for each task, whether if there is a commitment yet, whether we can commit to it, or is it complete? Something like that. So here, if we can go to the project details, we have another parameter that is the multiple commitments. So multiple commitments is for this project 0001, we see that the multiple commitments is true, and that means multiple people can work on this task. It's designing a project card. Project card is what we can see right here, right? So for other tasks, we don't have to like a different. Many people doesn't have to work on that specific task because like if one gets done, then it's the same thing, right? This is for design, so it has been set true. So if we look at it, if I can scroll, I think I'm just gonna say it out. So if we look at it, we have multiple commitments set to true, and another one multiple commitments set to false. And there are another three cases. I really want to. There's something else that I can draw on, make a table. Okay, I'm just gonna go ahead and try it in the text file. So we have multiple commitment as true and false, right? And there are other cases that we want to deal with is if there is commitments there or not. So no commitments yet, and if there are commitments, and if there are distributed, if we've distributed all of the commitments, so it's done. So for this case, we want the project to be open, right? So if multiple commitments is true, then we want all of it to be open for this specific. Like if the multiple commitments, right? And if there is no commitment, we can of course commit to this. And then we don't want anything anyone committing to it if there is already a commitment present there, right? So closed, and if the work is done, then we also want it to be closed. So these are the things we want to achieve here. So if we look at this and there are no commitments, then it's going to be open. If even if some people are working on it, some commitments are active, we also want it to be open. And if the work has been distributed, we still want it to be open because multiple commitments, people can work on it further. And for those that multiple commitments are not set to true, then this is the case, right? If there are active commitments, we want it to be closed. If it's done, then it's done. So the way I approach is I pull all the transactions that is going into the escrow, right? And then also all the transactions that are going out from the escrow, right? So these things are the one I have grabbed from a GraphQL query, and then what we have to do is basically set a couple of filters, go through a couple of filters and see if which one it lies, it falls into this category. It's falls. So I'm gonna go ahead and in the code, I have work on the report runs, and so I'm gonna go ahead with this component file first.
Hey, Nelson, sorry to interrupt. Can you just do a quick zoom in on each of those windows a little bit? Thanks.
Fine. Then we'll go plus here. Is it fine? You guys can see this? I don't know how to.
Yeah, you have to go into settings to to change that. That's Ubuntu for you, older
Okay.
Nexon.
Okay.
Yeah, I'm looking fine.
Don't worry, don't worry.
Right.
Thank you.
So this is a completely new component that I have put in the tracking directory. You can see this in the Visual Security. So we have this components here, and for the data and tracking stuff, we have it in this tracking folder, right? So this one I have put it here. It's a new file, and so what comes inside it is the filters. First, I'm gonna go. I'm gonna talk about okay, this index page, right? This is the index of the showing all the projects that have been put in the GPT, right? So in that page, I have okay, it's in project card now. I can show you this one. So we have the projects index, right? And this is the page that is here. So here, each of this project card is from here, and this has been kept as a separate component in a separate file. So the edit is met here. I'm gonna show it in here, so you guys can see what I've changed here. As I've said, I did two set of queries. These are all the transactions that have been gone through the escrow, right? So I queried all the transactions that have been gone through the escrow. And again, similarly, I did a same query that all the transactions that goes out of the escrow. And what I need from here is to filter out for each project, right? Each one. And so we have the metadata, right? And how we filter out is through the ID. Each project has different IDs, and we want to filter for each out using the IDs. So the IDs are present in the metadata value. So this is an important value. So I got it from the queries, and the other thing is the tokens that are present in the transaction, so that we know who is committing to those stuff, right? I said ID and I should be. So this is the query part, and this is the fetching part. This is the escrow address. This is the variable to the queries, and same. This is from transactions going in the escrow, transactions going out from the escrow, right? So these functions are the ones I wrote in this separate component. So first is the transactions filter out by ID. So I have that set of transactions from the query, GraphQL query, and I want to give them which ID I want to give it, provide it to the function, and I want to get a result where it gives only the transactions that belong to that project, right? So we make a new variable result, empty list of transactions, and we map through the transactions, went into the metadata, and from the metadata, the value, the ID, right? If it's same as the ID provided here, this one is going to be the corresponding ID that is showing up in the front end. So this is a parameter we fill in, and we have this in the transactions. So if those are equal, then we push it to the list. So by using this function, we get the set of transactions that are specific to that project, right? Then again, so all right. So here I get the transactions belonging to that specific project card. This is a project card file. So each project card is generated using this file. The project parameter is here. So using that, I provide the query and the project ID. And here we get the transactions that belongs only to that specific project, right? So this is the same thing. This one are the transactions coming in the escrow specific to the project. These are the transactions coming out of the escrow specific to the project. The same function, right? And then we can go ahead with the next function. Commitment status. I think this one is first, right? Get commitment status. So here we want what we do is we give the transactions that are coming in the escrow and the transactions that are coming out of the escrow, right? This we can this is to generate the whole set of categories, these 6 things. But if we like, let's not think about it for just for a moment, and I'm going to come back to it later. If we just think about false, like if someone is, doing it, then we don't want anyone to be to commit it more, like, then we can think of it as false. Then the logic here is, if there are transactions that have come into the escrow and it hasn't gone out yet, specific to that ID, then we have an active case, right? If the transactions that have came into the escrow and went out, then all of them has been distributed. And if there are no transactions that have come in at all, then we have no commitments, right? So no active commitments. If there are no transactions yet that have come into the escrow, then we say it's open for commitment and there are no commitment tokens yet. Otherwise, if there are commitments that have the transactions that have come into the escrow and it has not left the escrow, then we have active commitments, right? Then I did this set of tasks that filters out the token name belonging to that transaction and return those names. So closed and those token names, right? Then if it's the other case, else, I have not given any condition here. So the remaining case is transactions have come in, all of them has been distributed. So the project is done. There is no active commitments and the project is closed. But if multiple commitment is true, that thing we put here, if the multiple commitment is true, then we still want it to be open. So open for commitment. Again, empty token names, no active tokens. And similarly, if multiple commitments are true, it's again open for commitment, and the active tokens that are in commitment. So I think that's fairly simple. And so these are the functions. So we got the transactions. Now we got the status. Those are that are either they're open or closed, and if there are active commitments, the token names. So once we got that, we just have to display it out. So if it's open for commitment, then this condition is just to set it for green and red. I'm going to show it to you guys when I run on the local post just in a moment. And this one is for this page, right? This page. Now, when I go, okay, so here the thing is, I haven't displayed the token names at this project cards. I have just shown whether they're open for commitments or whether they're closed. And once I go inside here, I want to show the commitment status and the commitment tokens. So these are the specific, these pages basically for each project corresponding to the ID. We get a separate page, detailed page. And here it's the same thing. I queried transactions coming in. I query transactions coming out. I filter out those transactions corresponding to that project and then get the status, right? And here is the display, right? Commitment status. And if it's open or closed, the condition is given here. And live commitments. And okay, this one will be clearer if I just show you guys how it looks like. So here I'm gonna run it on the local machine. This one is the pre-production version. So I'm testing it on the pre-production version, of course. Right. So yeah. When you go here, it's loading because it's doing the queries, and we have open for commitment. The thing is, a lot of commitments have been gone through this specific project, a lot of like for the testing purpose for the report version. So even if they have been distributed, commitment has been done distributed, it is still open for commitment because that thing that multiple commitments is set to true. Multiple commitments allowed, so it's still open for commitment, right? I think I did pick up, so it's and so if commitment is not allowed, multiple commitment is not allowed, it's closed. It means a commitment has gone through the escrow and it has already been done. So I think for testing, I have made a commitment here, and that's why it's showing up here, like commitment. And that's how we basically that's it, I think. And the part where we safeguard is all of this is these are just visualization, right? It's like in a game we're saying that verify your 18% and we click OK and then just go into like Then for that, we have the commitment button here. And for now, I can do a detailed one, like disable this button or something. But for now, what I have done is simply not to display this box at all if this commitment is closed. And that part has been done in a separate commit. Yeah, it's simply just this line, changing these lines of code. That is, if it's open for commitment, show this box. You can see this box. Otherwise, just don't do anything. It means don't show this box. So let's see a closed project, right? This is closed. And here we don't see that commitment box, right? Something we can do is to make that button disabled even after showing the box. That we have to pass a parameter here in the commit project function, and then you can still achieve it, right? So I think that's it for what I've done. If anyone has any questions, right.
Beautiful, beautiful, beautiful. Nelson, thanks for this and for the on-the-spot presentation. Really, really cool. I got a couple of questions, but I want to hear from anybody else first. Technical questions, implementation questions, anything for Nelson?
I've got a quick one. Is there much of a delay between sending the transaction and having it actually show up as closed if it's not set for multiple commitments? And could that possibly be an issue?
Yes, yes. Okay. So yes, actually, this is simply we're safeguarding it from the front end, right? What we have done is simply made that button not to appear here, right? So during that delay, if the button is still present during that delay, then someone can commit to it. And before I did that, it's actually what has happened to this pre-port escrow, right? This one, I think this one is fine. So project ID 002, multiple commitments are not allowed. That means if someone has already done it, no other person should come back and do it. But we can see that there are multiple commitments and multiple distributions already present for the big project, right? 002, right? Here you can see there has been a commitment and that one is distributed here, right? This is commitment, this is distribution, commitment, distribution. Of course, this is for the testing purpose on the report network, but it's still going to work on the mainnet because we're just safeguarding it from the front end side and it's not anything on back end. So if the button is still present there, yes, of course, and they commit to it, right? Did that answer the question?
Yeah, it did. Yeah, I suppose maybe a solve is to do it locally where if one person, there's some sort of a timer where if someone has clicked on the button, then it's somehow disabled for X amount of time. Kind of like, with what has been happening with just sending transactions, say with NFTs or whatever, there's like a little timer. But obviously in this case, I don't know whether it makes sense to actually show a timer or not, but I don't know, maybe just change state to like orange or something to show that someone is inside that room, kind of thing, or something. I don't know, occupado, or something like that. But yeah, thanks for speaking to that.
Yeah, thank you.
It's really interesting that that state shared across the internet requires another server, right? So here's an entry point for needing a GPT backend. And this one's really interesting to think about because, first of all, we're not, I don't think we're at the scale where it's going to happen very often, right? Where two people are thinking about committing to the same thing in the same moment. So it's absolutely an edge case, but very much a real one. And it's one that only applies for a couple minutes of time, right? So as we continue to think about the word decentralized in a decentralized application, what's the best way to handle those couple of minutes, right, where that edge case is possible? We have to, right? This is not production ready if we just kind of sweep that under the rug and forget about it. Oh, it's not going to happen often enough. We have to handle it. And by handling it, we're very likely to make this thing less of a decentralized app, which is really interesting, right? So I'm happy that that question emerges, and it's another thing that all of us can start thinking about. Exactly. And Yuli, that's the other part, right? So it's right. That's why. So you have what? A couple of minutes from submission time to confirmation time for the transaction itself. And then a couple of minutes. It's not long, but it is a measurable amount of time, the delay from the submission of the or the confirmation of the transaction to seeing it in a GraphQL query. And we need a private server or an alternative to a private server in order to handle that case.
James, real quick, because you said this and I've been kind of wondering it myself. When GraphQL, there's obviously a delay in responding this information from GraphQL. Is it actually a delay, or is it just that the percentage of confirmation or the number of confirmed blocks is higher than maybe what our expectations are, and that's what is considered a quote unquote delay? Is that it?
It's you're talking about the time between the transaction being confirmed on chain and it showing up in a GraphQL query, right?
Yeah.
Yeah, that any delay there is happening just because of the time it takes for whatever GraphQL server you're querying from, right? In this case, in this app right now, it's one of the Dandelion GraphQL instances that Roberto is running, okay? It's the time it takes for that service to record the transaction in the the chain database, the DB sync that the GraphQL is pulling from, and then to be able to present it. So not long, but not nothing.
Okay, thank you.
Yeah. This is actually, Nelson, I really like this implementation. So before I ask if there's any objections, I wanna just level set here. And can you click back into the list of projects just so people can have this in mind? Later, when we are working on client-facing projects with an instance of this, for example, there will very clearly be many things that only need to be done once. And this is going to be critical functionality to achieve that. For right now, the main goal of this first instance is education. And so a lot of these, personally, I'd be okay with all of these being multiple commitment ready. And that's another thing we can continue to talk about on Thursdays. But Nelson, do you feel like you learned about the inner workings of the app? Like, is that hypothesis coming true? Do you feel a little bit more confident about how it's built?
Oh yes, so very much. Like After doing this one, I think this two. I mean, I have an idea how to proceed on that. Like, so starting this one took us a little bit of time, and I'm pretty sure that if I work on this other two, then it would be maybe a couple of days, like 2 days. I don't know. Now I have the idea how to, proceed on working on the other ones. Like, yes,
Yeah.
of course, I've learned a lot.
That's awesome. Thank you for saying that. And it's really good to hear that. And as I was watching the presentation, like I was looking at the helper functions you wrote, I was like, okay, yeah, those are going to be helpful elsewhere too. So it's wonderful that we now have these commitments. I agree with Yuli in the chat. This is another little project that we could list here. It'd be fun to see who did the commitment. And so maybe that's part of task 15 or 16 that we're looking at right here. Maybe somebody else comes along and adds that to Nelson's work. Very cool. I don't object to distributing this project personally, but there is one thing that I want us to tackle together next. Like, I think this served its purpose. I think this is still not enough compensation for what you just did, the rewards in this task. But one thing I noticed is that we are making those GraphQL queries in every project card component. Okay. And so that's why you can see all of them spinning at once, obviously, and that's not going to change. But it would be a more efficient solution to make that query once one level higher, maybe outside of the card components. And then after pulling that data into the local state of the browser application, passing the results of that query to each of these cards as needed. Does that make sense what I'm saying?
Yeah, I got it.
Yeah.
Yeah.
Okay. And
Yeah,
right, so
I think I can make the change. Yeah.
if you have time, go for it. I do think it would take a couple of architectural changes though. So I think it's also fair to consider that like a next project. Okay. Because you did it. You implemented project commitment status. And what I'm suggesting is a way to make it now more efficient, right? Make fewer GraphQL calls and therefore have a more performant app. So personally, I'm still okay. I want to distribute this one and maybe even list that, what I'm saying, as the next thing.
I'm just happy that I got it done. Like this, I did not know TypeScript, and now I'm presenting my TypeScript functions and everything.
I was gonna say.
It's so cool.
I was looking at all your type signatures. I was like, he didn't know TypeScript a few months ago. That's pretty cool. Congratulations, very cool. Anybody else have questions or objections before we say that this thing can be merged with the repo and it's fair to distribute 2,000 gimbals and 100 data? We're in these early days, right? And it's together we're going to learn how to ask each other hard questions too, right? Because there will be objections in the future. So it's really exciting. But thanks everybody for taking a look at this together. I'm really thrilled. I'll review the merge request, and what I'd like to do is have it merged with the project and even visible on mainnet. And then tomorrow, let's launch our live coding GPTE governance session by distributing this one. Okay, I'll start with that and just give a quick picture of what that looks like before we jump in.
I'm gonna go ahead and stop sharing the screen so I can see you guys.
Awesome. Thank you. Congratulations. And thanks again, everybody, for being here. Very cool. Mix, hey man, we jumped in. We weren't sure when to expect you. Thank you for flexibility
Hi
to that.
everyone. I'm sorry, James. I'm sorry everyone for coming late. In fact, my alarm was off for around maybe 4 months. I was, I was setting my alarm based on the time before around September. I mean, we used to have changing the time that 1 hour. That's after changing from the summer to fall, and I didn't update that. So from all these months, I was coming to this session 30 minutes late. But anyway, I'm really sorry. Everything is now ready. In fact, I was working on it right now. I was creating some diagram to explain the whole concept, and I couldn't wait to explore many stuff with you, because I happened to face many errors that was, I think, made for many of you, maybe all of you, is strange. And in fact, I was going to show you the maybe first case of how you can lose your collateral if you mess up with this transaction and so on. So yeah, I mean, I don't know if I have time, I can give you a small tour about the whole concept, and we can set if you give me another chance for next week. I promise I won't mess up, and I will come at the right moment. So I don't know.
And don't.
What
hey,
is your
don't-
verdict, guys?
No, I'm sorry that you were spending so much time on that too. And please, no problem. Of course, dude.
No, James, because you said, yeah, I mean, last week we talked about TX info redeemers, but we in our project in Equival, we always thought about tokenomics and the tokenomics, how we can approach a tokenomic differently, something proof of work, something that you will work and minted based on same thing, like Bitcoin. And I was thinking about this, but when you say that, can you present this idea on how you can embed another contract redeemer inside another contract? It's like using several redeemers in one contract. Actually, after that, and when I talked with Janti, we may found a way to create a proof of work of a tokenomic. So we don't need to mint all the tokens, hold it in some place as a vesting or like a wallet, and then distribute it to people. So this approach also doesn't need multi-signature for minting. Like imagine there is I don't know, maybe do you guys want me to share because maybe the sharing I can explain this better. I know there are a lot of things inside this, so I know there is no time for that, so I'm sorry for this. So the concept, if you can see my screen, can you see my screen?
Maybe zoom in a little bit.
Yeah, sure, but just okay.
That's good.
Yeah,
So the
see it.
concept is we have two contracts. One, I call it the regulator contract, which is a minting contract, and we will go through it later. And another is what I call a distro contract, which the job is distribution of token. And in this case, because of many limitations that we can talk about it later, I choose two developers. So let's say we have a project, and that project has a developer team, or let's say private investor, whatever. There are several people, and they want to obtain their percentage of total token they are going to mint. And since, if you guys know me, I am very fan of Cody's law and not trust. I mean, keeping the trustless and permissionless of a smart contract blockchain. This design pattern can help in that. And I don't know, maybe you know, for example, in Indigo project or other project, in order to do this, in order to distribute the tokens between each other, they create a simple or native script, and they put all of their signing key inside it. And then when the times comes, and there are some rules that you can implement inside the native script. But anyway, when the time comes, for example, if there are 10 people, 8 out of 10, 5 out of 10, or 10 out of 10, any number that they agree, they come together, mint those tokens and send it to each other wallet. So that's the idea of how you can distribute those tokens to each other. And if you guys follow Indigo, one of their developers left their project, and in first minting process, he got the token, and right at that moment, after maybe several minutes after that, he went to the some DEX and dropped all of his token, which made the price of Indigo crash very drastically. And the drama happened, and they said maybe we will stop him to come for next. And they agreed 8 times they will come together and mint and share all of their sharing the token to each developer. So in that, maybe there is a possibility, so the other developer can stop one developer or any other member of project to not be participant on this other phases of minting those tokens. But this design pattern can stop it, although those problems might happen, but this design pattern can stop it. And the design pattern is inside the regulator contract, which we can see it here. There are, this, we can see that, let me zoom this one too. So there are several redeemer. In the data type, we can see that the regulator action is Genesis mint, which means that we will mint at least one token, and we will put inline datum, which will hold all the necessary information for validation. So we are using the datum, the blockchain, as a database to validate that. And that there will be the first developer action, a second developer, and regulator debugger, which is a person who has a full control over the minting contract. But it's just for debugger, we can remove it. But anyway, Genesis means, that the whole contract, the minting contract, has the regulator parameter. And inside the parameter, we are, directly put all the necessary information that will be inside inline datum, inside parameter. So we have same data inside parameter and inside inline datum. And inline datum of UTX, so it's going to the distro contract. And inside the contract here, we are checking these are same. By the way, this is the new design for creating the smart contract in the pattern guard manner. It is different. It is same as case. So if you remember that, for example, I think I have the old, yeah. So if you remember there in the project 2 or 3, or in the bounty escrow, we are using case, the case of this, and we will handle all the condition of datum and redeemer. But we can apply same concept with pattern guard. And I will go detailed, but there is no time for that. But
I recently
bear in mind
switched
that
this pattern, man, and it feels so much better. Yeah.
Yeah, but there are some drawbacks to it. I actually created several files from same team, like compact version of that, different version of them, so we can compare it. And then if you go with the highest optimization, you will find that normal case of, and with going with the case of and case of each other and maybe even nested, you will get around 500 bytes less than if you go with pattern. But this pattern guard is much secure and safer. But we can discuss that. But anyway, as you can see, I'm here just these conditions are just checking that output UTXO, which is going to the distro contract, and we will validate it. Is it same all the fields, and we will discuss it later, or what are the fields? Same as the parameter, the contract parameter or not? And after, I mean, if everything's fine, and with this, which I created some contract, sorry, bash script to check with it, and inside the script, we will check it together. But what is important is first at the first developer action, and I'm giving inside the developer, inside the redeemer as a parameter, the address of developer. And inside the contract parameter, I provide same address, and I'm checking these two are same. And why is that? Because I'm going to use same thing, same address, and same thing inside distro contract. And let's just look at in distro contract too. So distro contract is going to be case of I wrote inside as a pattern go-to and call it nice because it it's look nice. But anyway, the code is case of first the datum and redeemer. The datum and redeemer of the distro contract, this, as we already know, the normal one. And then I'm going to get TX out inline datum. So I'm going to get the output UTXO, the inline datum of output UTXO. And then, by the way, this case just to create different hash of same contract, it doesn't matter. But anyway, after this, again, I'm going to use another case. And this is case of the result of this function, that if I get the inline datum, okay, then there should be a pattern. And this pattern, this is the inline datum for output, would be this. And then if I get that, I will run another function, and based on this, I will do the validation. This function is going to get the minting contract redeemer and use it inside a spending contract redeemer. Sorry, a spending contract. And sure, it's a spending contract redeemer too, but it's, as you see, is nested. It's inside of this case, and then we will reach this level. And if we look at that function, this get minting redeemer is against pattern. We can write it as a case, but this looks better. The whole idea is it will look up. I mean, I'm using the function lookup, minting minting and script purpose of minting and currency symbol inside TX info redeemer. And just let's look at this. What is this TX info redeemer? Very quickly. So TX info redeemer, in fact, is map of script purpose and redeemer. And by map means it is a list of tuple. And that tuple, I mean, if I want to write something like this, it would be a list of tuple that first, it would be, if we go into script purpose, it must be one of these. So the first element of the tuple is script purpose, which consists of two things. First, the purpose, the actual purpose, which is minting, and then one parameter front of that, which is for minting, is currency symbol. For spending is TX out. Let me just make it for this, make it more better. And then so we call these keys. I mean, normal Haskell understanding, we call these guys keys. So the first element of this tuple are keys. And then by lookup, we are searching the first element of this tuple. And then we will extract the second element, which is the value. And what is the second element? The redeemer. So the redeemer of these contracts, or redeemer of spending, or for rewarding, same thing. Redeemer. And as you can see that since it is just a list, the lookup function will look into it, and redeemer. So after the searching, I'm going to search that I want inside this list, whatever it is, I want a tuple that first element, which is the key, is minting, the purpose is minting, and the currency symbol, the currency. And what is the currency symbol? I'm providing the currency symbol inside the spending contract redeemer. And inside data type, we can see it that in the distraction, which is the redeemer, in phase one, I'm provided the currency symbol. But you might say that this is redeemer. Anyone can change it, or anyone can provide different. But I'm checking inside the contract that is this minting, this currency symbol is same as the minting contract or not. A minting contract, since I happen to mint the Genesis token, and which I call it happy, I mean, the name of the token is happy, is the same. So the policy ID, the contract, the script hash of this contract is same as that token, which the developer is going to get. I'm just checking that. If it is same, so I can be sure that the same minting contract that I want present inside the transaction. So then after founding that redeemer, I will return that raw minting redeemer. So it will return raw redeemer. And then I'm going to use some kind of destructure, like deserialization. And then by this unsafe from built-in data and provided type application, I'm going to again serialize that into regulator action, which is the redeemer for minting. And then after getting that redeemer, I can follow the redeemer's pattern and using the first developer action and the address and going inside all these conditions. So the idea now, as I think maybe you got it. If you don't, please ask, that I use another contract redeemer inside this contract. And that contract now for this specific design is a minting, but it can be another spending or a rewarding contract or certifying, which is rewarding. It's for withdrawing a stake amount from a pool, but for the contract. And certifying means for delegation. So yeah, this was, and I create some diagram to explain whole concept of this guy. We will go through, we can go through it, and also some bash script to test it and finding what is the problem of this design pattern. I mean, In my opinion, there is no problem, but we hit the hard limit. And how we can solve that? And here I can tell you that why it is necessary to teach still teaching people about Plutus version 1. Because if you use Plutus version 2 as style of transaction, you cannot work with this contract. You have to go with Plutus version 1, and there is no other way. I mean, we can discuss about that.
That feels like a rug pull.
Yeah. So
This
if
is
you
a
have
mind-blowing design pattern, but what, like, is this? Are you predicting that it will not be feasible given at all the architecture of Plutus V2, or is that kind of?
no, okay, let me just show you. So
And I should say, I really do have to jump off. Can we go 10 minutes more and do a hard stop in 10 minutes?
Sure. Just I want to show you the error. So if I won't go through all of the combining and so on. Just I'm going to and also I happen to create let's say that reference UTXO. This is the bash script to run to create a reference UTXO. Everything's automated, and in future we will go through that bash how it's working, but it's just creating a reference UTXO for distro contract. And then after several second, maybe 10 seconds, I'm going to use same different bash script for creating the regulator reference UTXO. So we are going to use for both of those contracts, the minting and spending, as a reference UTXO. So we do not want to write the file, but we will see what happens. So I think now it's okay to do that. Yeah, okay. So now I'm going to do minting the Genesis token, which will check the output inline data. Is it same with the contract parameter, the minting contract parameter, or not? By the way, since never mind. So everything looks good. I mean, we will go through it, how this thing works, because there are many stuff inside that. There is a process how to can compile it and how to interlink this contract with their JSON stuff. But anyway, let's say this works now. But now the first developer wants to redeem, or not redeem, maybe claim, mint its share of those tokens. So first developer claim phase 1. And everything again is okay, but we are going to see maybe for first time this error. And the slot number for now is current slot number is this one. Sorry, what's the problem? Okay, there are two contracts. Oh, that I sent it before, but so I don't know. Do you let me zoom this a little bit so you can see this weird error? I don't know. Have you seen this error before? So this error indicates that my script size is okay. The CPU step is okay, but the memory usage of these this contract is way off the limitation. And the limitation here is different. You know, we have two limitations right now, and I'm going to explain it. Here, what's happening is limitation of fee. You know, at the most fee you can spend is 2 ADA, 2 million Lovelace. You cannot pass that limitation right now. And all the calculation of this CPU step, memory usage, Plutus size, everything inside the amount of UTX or several UTX or output, input, whatever, it cannot pass 2 ADA fee. It must be below it. And at this level, when your transaction fail, it means that all the calculation of that transaction will produce a fee more than 2 ADA. And this error now shows what exactly is causing that. And that is usage. And if maybe this is around the this is 5,699 bytes. And this, if we convert it to Lovelace, maybe it's around 56,000 Lovelace. So the whole fee right now is 2 ADA 50,900 something Lovelace, and that's against the protocol. But if we can pass this, there are some. For example, let me show you. There are some switches that can pass this step, but that will make your node can pass it. I mean, you can submit it to the blockchain, but budget. Extra. Never mind. I mean, I can't. I will show you later. I mean, there's no time for that switch. But after, if you use those switch, you can provide some arbitrary number of memory usage and CPU, and it will pass this level. And it can, you will have a fee of like 2 ADA, 3 ADA, 10 ADA, whatever. And again, you can pass the last for submission because that's another bottleneck we have to look at. But the next node, the exactly next node, will look into this, and since they are working on default protocol and default all the numbers, they say that okay, your script, your transaction will fail. It should fail because of messing with the stuff, and it will consume your collateral and send it back the rest to the changing address or the address you're providing. So
can I make sure I'm hearing that right? Can I make sure I'm hearing that right? So we're moving from protocol V7 to protocol V8.
Yeah.
And in protocol V8, that transaction error right here will result in lost collateral?
Right now it is 2, but in protocol V8 2, I mean, that will happen too, because in protocol version 8, they didn't increase these things.
Okay.
For some reason, still IOG wants to keep all these limitation intact. So they don't want to change it. But in future, maybe we will have some upgrade. So maybe this will be flexible, or maybe they will increase this memory and CPU step and the 2 ADA fee. So we will have like 4 ADA fee and something like this. But
what I'm struggling to put together is but it's a transaction build error, and I have to submit a transaction in order to lose that collateral.
But you can, there are 2 steps for transaction error happening here because of this. I mean, we will explore it later. Yeah. First, here it's before transaction building. So one error happened here. We can pass it. We can bypass it with those switches, or we will do sub optimization with the contract, and we have all these. I mean, here I created all these different versions of the same contract to just bypass it. Also inside the script itself, here there are some other switches that is ready, And if we use that, we will pass this step. But is some of this contract, again, it will fail at submitting, and then you will see that, oh, yeah, now this is the second hard limit. So this is the first hard limit for 2 ADA fee. The second hard limit is for the memories, which is 14,000 memory. But you can bypass these two limitations by providing memory execution and CPU execution arbitrary number. Here, there are switches. I forgot which was, I think. I now I do not recall the exact switches, but anyway, there are switches inside Cardano CLI that you can bypass that, but you can submit it. You can do it. But if you do that, the next node it doesn't validate your script, and it will consume a collateral. We will try it together. I mean, don't worry, we'll try it together, and it would be fun that you can see that. Oh, so now you can try. I mean, you can see the beauty of blockchain. So you can do something in your local machine. You can convince yourself or your node that it's okay, but the next node, the next guy, doesn't go with the trust or whatever. The code failed, and you have to pay the price.
Very good.
So again, I'm sorry for coming late, and there is a lot of things that I wanted to share with you guys, and maybe even 1 hour, 30 minutes wasn't enough. And,
there's no chance it was going to be enough. Yeah, but no, you packed some mind-blowing stuff into a short time. And as always, I'm going to need to watch this one again. But I can already see the applications for this pattern that you're playing around with here regarding script purpose and yielding a redeemer if initial conditions are met. And this is going to enable us to do some pretty cool stuff. Thank you.
Yeah, and this function, and by the way, I'm going to upload this code. I don't know if it's possible for going for next Wednesday for going through this code.
Yeah.
Or maybe for the whole course, because there are many things that we will talk about here, optimization,
Exactly.
different design pattern. But anyway, I really recommend you guys to look forward into the TX info redeemers, how you can implement different redeemer inside the contract. And you will amazed at how many design pattern can be happen, but unfortunately the limitation is right now is Cardano blockchain, and there are ways to bypass it, and we will discover it later how to bypass it.
Thanks.
I'm assuming.
Okay.
Yeah, just a super quick question. Bypassing all that stuff, I'm assuming that on a side chain, one could basically choose to implement for that transaction to actually go through.
Yeah, you can create a same. Actually, there is a plan for that in IOG, that's creating same Cardano blockchain as a parallel chain, not a side chain. Because the side chains sometimes happen is all the security or validation would happen inside the settlement chain, like a Cardano. And then there is a side chain, let's Milkomeda. You go with all those compilation, the fee, everything would be different. And then the last result would be submitted inside the Cardano. But there is an idea called parallel chain. So imagine we have two separate Cardano blockchains at the same time. And both of them are settlement layers. So both of them can have different side chains. So one Cardano blockchain can have this limitation for 2 ADA, another Cardano blockchain can have 4 ADA or whatever, and that blockchain can have its own side chain. And that side chain and a Hydra, everything. I mean, and also this parallel can work together, but still, I don't know how. I mean, Charles Hoskinson was saying that they are still working on those protocols, how these two parallel blockchain can work each other, because they are running on different protocols and different stuff. I mean, by protocols, you can see that protocol parameters Cardano. Uh, I think Pool Ada or Pool Ada or Ada Pool something. They created very good, Ada tools. So inside the Ada tools, you can see all these parameters, and if you change one of these, you have to go with a completely different blockchain. So, yeah, maybe we will have parallel Cardano blockchain that can host different sidechain because of this limitation. And this, as you can see, this limitation here, for example, max block execution memory, or a step, or max TX memory. I mean, the TX memory, those TX memory here is around, this is 14 kilobyte, but it's 14 million bytes. I think 14 million, 14 million bytes or bits or whatever. But this is, I think, big bits. But at submission, we will hit this error, and we will see it in future. We will see that we will how to do it. But all these stuff that you can see, all these, if you change it, you are having different blockchain. So if these are hard limits, these guys, this max TX EX mem and max TX EX step, which is for the CPU, and this is on picoseconds for CPU execution. So it's around 10 billion picosecond is available. Right now, it's very hard. But maybe in future it will be flexible. And flexible fee for Cardano would be something like this. So this will be flexible. Right now, when they decided not to go ahead, and this is the side. And the side chain must again follow these two, because at the end of the day, that side chain has to submit the whole transaction, batch it, and follow these routes. But Cardano, since it's open source, we can have different, the parallel blockchain, and with different parameters.
That's crazy. I'm looking forward to that future. It would be like a braid interweaving. Cool, man. Thank you so much, Mix.
Great. Let me stop sharing. And so yeah, James left. So sorry, do you have any question, or no? Let's wrap up this session. And
Yeah.
we will we will talk about that future in maybe next Wednesday. Yeah, we will see the limitation, and maybe in future we will ask Cardano what they should improve instead of, I don't know, adding NFT. But this design pattern can be helpful for NFT project too. So imagine you are creating some law, and you do not need to mint those NFT and send it to the user. No, you can create that minting contract, put it inside beside a spending contract. That spending contract would be guard, or let's say, what is the name of that? It would check that what's happening with that minting contract. It would be like a bodyguard, or let's say the gatekeeper. That spending. And then user can come inside that transaction, interact with minting contract, and mint that same NFT and send it to their wallet. Without you spending anything, they will pay the fee, and you are just need to be careful about what are the conditions of validation happen. That can save a lot of money and a lot of hassle, or maybe it can improve the performance of NFT project, because they do not need to mint it and send it to anyone. Now people can do it. Or as an authentication token, let's say someone wants to access a website, they can come into that transaction, that minting for that access can check everything is okay. If everything is okay, that person will create that authentication token for themselves, keep it, and use it in that website. And when they want to leave, again, maybe they will go with another transaction. But this transaction is for burning, not for minting. But same spending contract, or maybe different spending contract. Again, it will gatekeeper, it will be bodyguard, it will check every condition happening. And you can use Datum, the blockchain, the transparency, trustlessness, permissionlessness of blockchain to go through all of this. So you don't maybe need backends, or maybe, yeah, there are things that you can do with this stuff.
Awesome. And also centralization, right?
Yeah,
And Maker and all these other different services.
yeah,
that
exactly.
all- yeah.
And for that, I think this can also, as our project, we are thinking that very truly that we do not want to mint that, because this process of not minting your whole token or whole NFT and send it to anyone, that is a place regulation, the government still do not have answer for it. You can say this is proof of work because you are not doing anything. You are saying, I'm not responsible for any person. This is completely non-custodial. I do not push anyone to buy this, send this, whatever. The person itself came here, used it, minted, and sent it to its wallet. So even regulators in countries, they cannot find you guilty of someone because you do not take responsibility of those tokens or whatever. That person by themselves mint that. So maybe that's a way to escape from that too. Escape from those regulations.
Yeah, no, that makes a lot of sense because it's this issue of securities makes it is a lot more problematic when you have a lump sum or sort of upfront minting, but then if it's as and when, then and it's as and when for utility purpose, then that's very different.
Yeah, exactly. And I think that although this is everything a smart contract, the blockchain is proof of a stake, but we can argue about that. This process of minting and validation for minting and spending, it's a work. So it's different kind of or different version of proof of work. And we already know that regulators are kind of okay with proof of work, and they do not consider proof of work, the result of proof of work, whatever it is, as a security. As a community or security? I mean, what is the problem? Security.
Security, yeah.
They do not consider it. But if you stake something, if you mint something, if you hold something, they will consider it as a security because they say, okay, this is now, it's like you mint something, you have hold of a good, hold of a product. So that's an argument. But with this design pattern, we can say, although the nature of these guys are same, this is same currency symbol, the token name, it is NFT, it is token, whatever. But since the process of obtaining that product or obtaining that result is completely different, it's proof of work. So it is not security.
Yeah.
It is a result of proof of work.
Right.
So we can change these. We can change by changing the approach, by changing this design pattern. Really, we can be a very good project and have a good relationship with the government, at least with current regulations.
Yeah, that makes a lot of sense. What are you going to say, Dan?
I was going to say, what happens when the person has minted their NFT? They are then holding the thing of value. Can the government not turn around and go, but you've just created a security, we're going to come after you?
The thing is, as the regulation I know of, if you mint that as a project, is completely different than as a person. If you are minting that as a project, you are saying, okay, you want to make a profit from that. You are selling that. If you send it free, it's okay. For example, Cardano had the issue with minting NFT for Summit NFT for 2021. 2 years ago, on September, they said we are giving people 7 different NFT if you find some hidden Easter egg inside that. They didn't mint that for 7 months because they had the problem of regulator that, okay, this is NFT and so this is security, you have to do this, but they said we are giving it free. Because of giving free, the government said, okay, you can do it. But again, same thing. They did it on the 2022 summit too. They giving it free. If you give it free, fine. But the NFT project cannot give that free. You know, that's the whole purpose of the business. So how we can comply to those regulations, but at the same time, we do not sell those as the let's say old-fashioned way. I think this can
pre-sale
be
kind
a
of thing.
way, and we can say, "Hey, I'm not minting them. I do not force anyone to use my smart contract. The code is in blockchain. Everyone can access to it. I do not force anyone to use it or whatever. I'm just validating, and then the person is minting by themselves." And there is an action of that. They want to create the security for themselves. I mean, okay, but if they go for selling, that's again maybe another things that. But I don't know about the U.S. law. Imagine there someone create a product inside their home. Can they sell that without having problem with the government? Let's say someone create a bench, or I don't know, a chair or car or something. This is same thing. It's proof of work of that person. But I just happen to use a guy. You know, I mean, I don't know. I mean, what do you think?
I think, I mean, to kind of go back to what Dan was saying, I think it helps to kind of take a step back and define what security is, or at least to define a particular aspect, which is there has to be an expectation of value created from a specific sort of like small group of people. Like, you know, in the same way, you know, if you buy Tesla stock, the expectation is that Tesla employees are going to create value, which will then, you know, be reflected in that, you know, in the stock price. If
but
one,
if
like
a person create a value as personally, not as a company.
Yeah, I know,
personally,
I know.
Is that a problem to personally,
I
just by
think
himself?
the difference is, like when you were talking about it, the first thing that came to mind, I was actually gonna point to what Dan just said. It's the equivalent of like going to a key maker and having a key made from like information, you know, which is freely available, right? But that key then is only in your possession. The only thing there is what are the expectations for the product or service which you're accessing, right? Which you're using that key to access, right? If there's a focused like few amount of people, you know, whose work is required to create a value in that particular context, and then maybe, you know, there's some incentive to burn, right? So then there's you know, there's something there maybe. But also, just to quickly go back to what you're saying about free, how are we defining free? Are we defining free as in the person pays for the fees, the transaction fees?
I mean, the free actually, what I understood based off the Cardano struggle to just
with the
meet
summit.
They said that it should be free by not sending it should be free by minting. I mean, so I mean, what they was saying somehow, and maybe I'm mistaken here. I really do not have very first-hand information. They said that if you want to mint that, I mean, you should not create that mint, like you should, Cardano, you should not mint it by yourself and send it to anyone, even free, even without anything. You must provide a way for user to mint it by themselves. So the exchange of value shouldn't happen. So imagine as that key maker way. The key maker, there is a shop. You do not go inside the shop and ask key maker, please create a key for me. That shop is different. You will go to that shop. Key maker will hold your hand, bring you to that workshop, and slowly teach you how to work with these tools.
Yeah.
Observe you and make sure everything is intact. And you, by your hand, will create that key. So the law for now, as I understood in US, if you do that, and if that person is creating another person house key, and he's going to install something or he's going to kill whatever, the key maker is not responsible for that. If you give the instruction. But if the person comes to the key maker and say, make a copy of this, and the key maker doesn't validate who is the person, are you the owner or whatever, the key maker would be responsible, not fully, but partially. So Cardano somehow bypassed something by this. But right now, many of our projects in Cardano, NFT project, they are completely doing the things that if the US regulation, at least in US, many countries are following US as a role model for following the regulator too. And even my country, Iran, is using many of the resolution that SEC or the committee in SEC, I mean the SEC or Ministry of Treasury in US, creating all those research, all those paper to study and to create regulation. Not this certain many countries, 200 maybe any countries. So the people are looking, really looking forward into what regulators create to a law inside US. So now, as I understood from the Cardano experience, the Cardano Foundation experience, you have to act like this. So you have to just instruct, holding hand. Although you have to do just validation, you should not touch that key at all. You should not touch that tools for creating that key at all. But you cannot. But you can provide those tools. You can create those tools for people to come in. At least the law for now. But one thing that still I don't know is still I don't know because they didn't do it. Let's say if you are going to mint that NFT or creating that key in that manner that I explained. At the end of that, you are going to give a money or something for the service of that key maker. What is that money? Maybe again that name of that money would change the law. I mean, you can bend the law or bypass it somehow. For example, that money is not a salary, is not a payment for the services. It's just a tip, it's a bonus. Something like that. If you maybe the changing the name,
it's it's royalty based. It's a royalty from a license, from a basically software license.
Exactly. That's it. That would be. So it is not like you are coming here and you have to pay this fixed price. So maybe if an NFT project say you are free to mint this NFT, but buy me a coffee, 15 ADA. Or donate some amount of ADA to me. And the minimum amount is, let's say, 15 ADA, or it's 10 ADA. But you can donate more. So you can actually sell your same NFT. It's just, as Roberto was saying, we are now a lawyer, which is a lawyer. So But anyway, these we are thinking that how we can change in the name, changing the process to make it good with regulator.
I agree. And actually, you know, going back to what I said about the royalty thing, I've been looking into it, and you know, one of the things I know from a tax advantageous standpoint is ever since I went to the summit in Switzerland, I realized that one of the benefits of Switzerland, you know, is that from a tax standpoint, royalties paid from basically like a license tax does not have a withheld tax requirement. Basically, you don't pay tax on royalties, and this is because, you know, a lot of R&D happens there. So, you know, there's a lot of incentive to do R&D in Switzerland, as well as to benefit from the results of that R&D, and to keep it there. So that's,
You
you know,
know, is it same thing in US? Like
no,
royalty,
I've
donation, you know, all these should maybe the non-profit or NGO or whatever,
yeah.
those organizations, do they pay tax based on their donation or buy me coffee or royalty or whatever, or not?
From my understanding, they do not. But then there are like certain requirements, you know, things like, you know, if you're a charity, you can't like be politically involved, or, you know, anything like that. Um, and in some cases, there's limitations with regards to, like, I suppose how much remuneration can happen in terms of payments of directors and dividends that you can pay out, and so on. But yeah, so just to quickly go back to what you're saying about the US, there's actually a term for what you said, which is regulatory harmonization, right? Where, you know, different countries just look to copy paste what, you
Yeah,
know, a different country has already done from a regulatory standpoint, and that has good things and bad things that, you know, go along with it. But at the same time, there is sort of arbitrage opportunity to really keep at bay the centralization and the abuse of power that that can bring with, you know, tapping into different regions who have different policies, like for example Switzerland, and, you know, whether, you know, other places like you know, the Caribbean islands, and New Zealand, even, like, yeah, just the differences, you know, from an arbitrage standpoint, whether it's tax or different laws. You know, I think it's super important to actually value those, and to tap into it. Now, to come back to this idea of eliminating the liability from the manifesting of the asset in terms of, you know, this access token, I think that part with this implementation would be solved, because it kind of becomes like a vending machine where,
yeah,
you know, you have to
exactly,
press a bunch of buttons, but
exactly.
you're doing that work,
And
right,
it
to
will
actually do
print a
that.
ticket for you.
Yeah, exactly. So, but then now the flip side is, let's kind of, I suppose, like give the example of a vending machine which spits out, you know, an Access NFC card to, I don't know, like a hotel,
Okay.
right? You know, you can go to your hotel room and, you know,
Yeah.
tap in, and have access to that room. I think the only point where there's possibly contention is the relationship between that process of the vending machine and where you can possibly be able to use it, and whether those people running that particular service stand to benefit by basically manipulating you know, the particular environment. A good reference here is actually airline miles, where, you know, you get airline miles, and you can only be able to, yeah, so yeah, there's actually, yeah, precedence here. Airline miles, you can only be able to claim. You can use them to claim specific things, but never use them to convert them into money, right? You can use them, across, say, different airlines within a particular, like
Yeah.
like Star Alliance
It's
or
like
whatever,
a
right?
coupon, but
Exactly.
dumbing a specific coupon. You cannot use that coupon in other airline or other places, but
Yes.
it's a coupon. It has a value, but it dominates in that domain only. Yes, you can do it with NFT, but we do. I mean, I think in some countries, I heard that people are trading that airline miles.
Mm,
And they are
mm,
using that as a means of currency inside that country, inside that. But it is not. It is not legal.
yeah.
That airline doesn't accept it. They say that we do not have any part of in this. We do not care. But people are doing that.
Mm,
I mean, fine. You want to do it, fine. I mean, maybe I don't know who is going to buy that, but anyway, because I think if a person who has enough money to travel a lot that can have big coupon, why he wants to sell that? I mean, if he is in the needs of money, I don't know, but maybe he's an employee of someone, but he wants to, like, he works for 1 year. I heard actually exactly like this. He works and travel for 1 year, and around that Christmas, he sell those coupon to other people.
yes, before they expire, because they
Yeah,
expire.
exactly.
Exactly.
And use those using the money from that, buying Christmas gift for his family.
Mm,
So he's traveling for 1 year, keeping and that, and a stacking accumulation of these miles, and then he can sell. But he won't sell it like a normal manner. He cannot even change it. There are some maybe a referral program, or he can somehow give his coupon to someone else, or like it would be a code, and he can go to that website and buy some travel by I don't know exactly the procedure, but yeah, that NFT, it can be NFT. You can actually upgrade that, and we are thinking in our project too that how you can upgrade that coupon. Let's say it is several tier, it is with different name, bronze, and it's gold, and let's say it's diamond, and then after, or platinum, and then diamond. Normally this is 4 categories. By this second approach, we can just mint, burn, mint, burn, mint, burn, and upgrade that. And your spending contract can monitor every activity, and you can be sure that everything is working seamlessly and correctly. I mean, we will look at how we can control it. But they want what you can say. We do not sell that. We do not accept that to sell it. But people can sell it in P2P manner. And you cannot, and the government cannot say something. You can say that I do not get royalty from that. I do not do, you can just separate yourself from this token, selling of this token completely. And I don't think governments or any regulation can put you in charge that, people are sending this to each other. So that you can say, what should I do? I cannot control any people's wallets, especially in blockchain, especially when everything, as you see inside this design pattern, is non-custodial. You do not hold any one person. You do not charge any one person. Everything is blockchain. You have problem with this fee? Okay, go find Charles Hoskinson and hold the responsible why the Cardano fee is this much. I don't like it. You see.
I mean, that's a really good point. However, I think it's important to, you're either regulated or you you create you create standards and sort of self-regulate. And I think it's super important because in this particular case, yeah, people from a P2P standpoint can go crazy. However, there is validity in the concern of someone paying someone else to do something, immoral or unethical, like, hey, here, go kill that person, or go kill that person and I'll pay you, X, right? So in a way, like, we need, whether it's, using zero knowledge, or, etc., to be able to prove that certain things have not occurred, right? As opposed to kind of like trying to track everything, and live in a surveillance state. That's one thing that I think we have.
We can do it. We can do it.
Yeah.
Hey, the SIP 68.
Yeah, the famous.
Yeah,
SIP
SIP
68
25
metadata.
define about NFT metadata.
Mm.
And inside that, we can say a lot of stuff, but your smart contract cannot and will not understand it. It's completely off-chain.
Mm-hmm.
But SIP 68 is going to create that standardization of the datum, which your smart contract can understand, and NFT metadata. So let's say your spending contract regulate this data, and that data must be same as that metadata. And inside that metadata, you can say this NFT is just for, I don't know, read-only purpose, or I don't know, access to this particular place. All the rule that you want to put, you can put it at the same time, the data and inside the metadata. And that would be, I think, same as someone write on a dollar. He printed out inside his home $1, but he will write, this is a fake one. This is for kids. This is for, joking, whatever.
Yeah.
The government will not respond. Oh, you are printing money. You are, challenging U.S. government. No. Look at this. I put it with bold and with around 70 font size. That this is joke.
Yeah.
So I think that would solve the issue that I'm proving that I am not responsible. This NFT is not the one for selling or whatever to anyone. And also you can bind that NFT. It is possible. We can. I didn't do it inside this design pattern, but we can do it. We can bind that NFT with that person's wallet. So even that person send it to any other person, he cannot use it.
Yeah, because the validation won't clear.
And how we solve it in Equival with this manner. The token name would be the person address. So the wallet address would be the token name.
Oh, you might have a problem with that because I've been here before. There's a limitation to.
Yeah, but I solved it with 2 tokens.
Oh,
I
okay.
just split it. Yeah, truncated. I split it into, and I call it key token, lock token. Let me show you how this.
Nice.
Let me show you a little bit of the code that I wrote for Equival. The project that I'm working. And inside that, I solved this issue. Because we had same problem and we wanted to fix this because we have admins, and that admins are not people. They are API wallets, or in Mesh they call it. It would be a wallet that's a program. It is a program. So inside the. So I'm putting these 2 tokens, and I call it EAAT, Equival Admin Authentication Token. Inside the script, I mint those tokens. Let me show you the script. It would be very creative minting. Sorry, I should put it in. So if you can see, there are several authentication tokens this design pattern. I hope when we open source the whole project, you will see that. And actually, people can use this this design pattern. And there are admins. There is I call it. There is a master that has a master key, or let's say a skeleton key, and then that person mint super admin token. and that super admin mint admin token. And I can explain it later that why they did this design, but just for the security and for the scalability actually. But anyway, if you can see, this is the pub key hash of the address, the admin. I just split it, trunk into 2 tokens, key and lock. So now we have 2 tokens that I know the currency symbol because I can make it sure, and I'm using the token name for signing transaction. But you might say, wait a minute, Ali, this is hex. And maybe you face this issue too. Pub key hash is a hash. It's not hex. You cannot use hex inside that function. I mean, what function? This function, TX signed by. I mean, if you see this TX signed by, you have to have the pub key hash in normal hash, not in hex way. So I mean, so how did I solve it with this very nice? This is function. Let me. Where is it? Here. This function gets a hash or any built-in byte string and convert it to hex. Unfortunately, this is not available inside the Plutus. Maybe in future some built-in function can do it, but still not. We have a function inside Plutus called from hex, which will take a hex and return the value from hex. Although you see that Plutus we want ledger byte, but by the way, you cannot use any ledger byte stuff inside your on-chain code. This is for off-chain. So even this, there are a function, you cannot use this to get the hex value. So, but I'm working on it to create same thing for on-chain. Still, I wasn't successful. I'm getting some built-in error, but anyway, this is working. So I'm getting the pub key hash of the address, the same person that the admin or anyone, converted to hex, completely on-chain without anything off-chain. This is the normal way of Haskell for converting to hex. I mean, you can go and this stuff actually I copy it from someone else's code, but I just change it to the Plutus way, like empty byte string, like to coefficient rate, all using the like index byte string. There are built-in Haskell function, but we cannot use it inside. But all of these are built-in Plutus function, TX, Plutus TX, so we can use it on-chain. And then there is a function called validation of those. And what is this job? Is just first, I'm extracting the token. I'm sorry, I'm extracting the pub key hash of the admin address. This can be the minter guy or anyone that you are going to mint that token for them. And then here, I'm just concatenating those token names that you saw and return it as a PKH from EM80. And as you can see, I've used built-in byte string to hex. So I'm converting this first. I'm getting the pub key hash from address. This is the built-in function, get payment pub key hash. Then by this get pub key hash, I'm converting the type, only the type, to built-in byte string. And after that, I'm feeding the whole stuff, which is now is a built-in byte string. Again, the string itself didn't change, just the type it changed. I can really change this built-in byte string to pub key hash to hex, but that just add some complexity here. But by using one function, I decided not to go with that We have already a function to convert it, so why bother, you know? So now I have a built-in bytecode string, and then I feed it to this built-in bytecode string to hex, and now the pop key hash, the result, which is the hex of pop key hash, so it would be a hex. It is not the hash anymore. And then, and by the hex, maybe again I should show you that by hex I mean this guy. So this all, it is a number. It is, so this is a hash, this is number. So I'm converting that to this number, and then here I'm checking these two are same or not. That's all. And then I'm going to check is these the UTXO that hold these tokens, do they exist inside this contract or not? Because in order to make an input visible to your contract inside this function, you have to spend it. So by this, I'm forcing the user, which is a customer here for, I mean, is sending money and whatever is, you know, Equival, I don't know for you guys, Equival is a P2P marketplace. It's completely non-custodial marketplace.
Yeah, I was just checking out the website.
So these TX info inputs or output, the list is the UTXO that's going to spend. It's coming and going. You can put a UTXO inside the transaction and you don't need to spend it. If you do not spend it, you do not need to provide who is the owner. Therefore, you don't need to care about, you know, whatever. But I check in this and I'm forcing the customer to use admin UTXO. And since I'm forcing to use that admin UTXO, he has to provide admin signing key. So he cannot do something without the admin approval. So this can be implemented. I didn't go with this implementation inside the thing that I wanted to explain today, the design pattern. We can do it. And by limitation of Cardano for now, we have to use 2 tokens to hold this address. But it is solvable, you know. Yeah, it was a challenge for me. I took some time because I didn't know what's the problem. I went into the rabbit hole of what the hell is this, because I had to look inside the anti-Plutus core. I had to look and really going through inside that. Is it this is the Plutus core, and this is the, by the way, this is the this one untyped. That one was it. As you can see, this is the whole contract, and it will go and live inside the ledger, inside the blockchain. I really had to go inside it to find what is the problem. I see, oh, see now my value. If let's say, maybe I can find it here. Yeah, you see, this is the pop key hash of the admin. But by the way, this is a pop key hash, this is a currency, but let's say they are same. So inside the UPLC, which is an anti-Plutus core, I found this and I saw that, oh, this is hash. I have to convert it to hex. And then I went through the whole process of hexing that. And maybe you can see, this is the process of hexing. As maybe you can see that there is 2 parts. It's going to do some stuff here. You see that function here, this function is, where is it? This guy. In Haskell would be look like this, but inside the Plutus core, it would be this. And this is the, I mean, the result, but anyway, but there are some, so this stuff, I had to write that down. But you can see that's very complicated, and you see. But
and this is prettified. I hesitate to
yeah,
imagine
if
what
you
is not
if you raw,
prettified.
okay, let's go with the raw. You see, let me just if you see at the right side, this is the size of purified. So it eliminate a purified, by the way, is a built-in function. After I created some compiler stuff here, the option here. After compiling, you can see your contract budget. You can see the Plutus size, core size, CBOR size, binary size, Plutus binary size, CPU size, memory. I was going to explain all of this today. Unfortunately, I couldn't. But next week.
Next week,
I'm going to explain what is it, and I use all this function here. And again, this code is open source, not equivalent. It's not finished, but the code, that code for the project today, I was going to explain to you. And I use everything here, and actually I add more stuff to it too. And inside this, I will get the raw form. And first prettify, which is pretty, and you can at the right side, you can see this is big. Okay, yeah, this is big. But let me show you the raw one. That raw would actually convert to CBOR and live inside the blockchain. You see that is a right side. Just look at how
that's
big.
a lot. That's a lot.
So this is an actual honest to code contract. Wow. And you can see these are all the errors inside my validator, and you see this and this function. But this is, let me say, this is untyped. This is the typed one actually. But anyway, but I think the naming is different because this should be untyped. This is untyped. This is untyped. That's anyway. I changed the name. But if you want to go into rabbit hole, welcome here. Go to the Plutus core and you see it. But I solved it, and I really, I really like. Really glad to share this code. And for now, you can go with 2 access token. One of them as a key, another as a lock. And you can go whole. If they sell it, no one else can use it at all. It's impossible to use it. And but you can control the metadata and datum to sure. That would another validation and stuff too. But again, the person, if we can sell it, he can send it to someone else. But it would be as a trophy, as a souvenir, as something that is important. So again, this can show to regulator that even a person send it to someone, it is not possible to use it
or access value. Yeah.
But let me ask you: do we want to do that? Do we want to rip people off from their, proof of work? Because we are talking about proof of work. Maybe they work hard to obtain these tokens. Why not selling them? We can separate ourselves from that, but why? Why limiting them? I don't know. It's like any cards, like Pokemon cards or baseball card that they can sell, or any stamp. Well, let make that sell it. Whatever, I don't know. By the way, Bernard hands is very high up. So go ahead, Bernard. Sorry, I'm sorry. Go ahead.
Yes, Max, sorry to interrupt you. You have got extremely very important, what you call it, tutorials there. That is why I didn't want to interrupt. Because what I have and what I need, can I share my screen? It's similar to what I'm seeing here, but you can tell me, advise me. I'll be very happy if you can help me get it. And then even what could be the cost implications if we had to do it, you help me, and then we work it together. We open source it, and then the other thing is the time frame. Because one thing I like, you really have got working code on Bluetooth. Your code is working all the time.
Thank you.
Let me just share.
Yeah,
Because
share your screen, Bernard. I
yeah,
unfortunately I have to drop off, so I'll just quickly speak to something while you put up your screen. Yeah, Mix, it's been super awesome having this conversation. I think the one thing which I would have liked to carry on, and at some future point we should definitely carry on this conversation, is the part where you mentioned the different tiers of access, right? Obviously
Yeah.
the different tiers are defined by some sort of input, right? Usually you pay a lot more to get, like, the platinum or the diamond and that kind of
Yeah.
thing.
Yeah.
So, like, I think there's still a question that remains with regards to how the, in a way, prepaid, because as I see it, like, this makes sense to kind of, like a coupon or like a voucher. It's kind of like a prepaid situation where, you have this card that you're then able to use at, specific, say, hotels or restaurants or hotels in this particular case.
Yeah.
I think there's something to be said for the prepaid part of it, which, you have companies like Starbucks, who make a killing with people using the Starbucks prepaid, and obviously people giving Starbucks money, and then Starbucks is basically able to be a bank, right, where they're
Yeah.
taking deposits and they're able to
Yeah.
leverage that.
Their coupon or voucher is actually minting a token for their customer only. Yeah, of course. Yeah, that's
Exactly. Yeah. So there's in a way, it's like an identity for a
yeah.
specific context, but you need to
Right.
load it. So I think that loading part is interesting, and it will be interesting to have
It
that
is
conversation.
possible. It is possible. In the second token, there is very a space around 8 bytes space for that string. We can actually, I'm thinking about it. We can implement those, maybe the hash or some kind of stuff in that last space of the second token. And that last space can specify the degree of that access token, or that it is VIP or whatever. So we can use those two tokens. First token, the whole space will be used for the address, but the second token, that last space again can be used for that different level.
Tiers.
So we can do it, and or maybe we can introduce the third token. I don't know.
Yeah. Anyway, dude, I'm gonna hop off.
Okay.
I was supposed to be
Great.
on a call like 7 minutes ago. But
I hope
always awesome talking to
next
you.
week we can go look into that design pattern, and would be very awesome to look at. And sure, we
Exactly.
can continue this conversation too.
Awesome. Peace.
Thank you.
awesome.
Peace.
Bye.
Thanks a lot. Hey,
So
awesome.
Bernard,
Max,
please, I just wanted to say that I want to stop recording. So
Okay.
we can continue or share, but we will stop recording so it wouldn't.
That's fine.
So I think if I click end, I would want. If, by the way, I don't know, I'm not sure if there is an end button here. If I click it, I do not know that I
Don't
will
end it.
close the session, or how can I stop the recording? Okay,
The
no.
recording. I'm
How
not
can I
very
stop the
sure how to
recording?
do, but what